Now let's talk about implicit differentiation. And implicit differentiation is something that people find pretty difficult in the beginning up until you really understand some trick, like the trick on how to do it. So first things first, what is an implicit expression? Usually you guys see expressions written as y equals something, you know, 2x plus 3. All the y's are on one side, all the x's on the other side. So this isn't an implicit formula. An implicit formula has x's and y's on both sides. So, something like x squared plus xy equals 6yx. Something like that. Or 6, yeah. So that's an implicit formula. So what you're usually going to want to do using implicit differentiation is to find dy dx. So if we look at this, basically we're going to take the derivative of all the different terms, and when we take a derivative, so let's look at this first term, we take the derivative of x squared with respect to x, and we know that that's 2x. Notice that the dx, the d letter is the same letter, the same variable that's in the numerator. So we have an x squared and we have a dx. So if we, let's say, I'm just gonna add a 6y out there. So if we wanted to take the derivative of that 6y term, and remember, we're taking it with respect to x, well, that doesn't really make any sense. We have an x in the denominator and y's in the numerator. So this is pretty much what implicit differentiation is. What we're going to do is we're going to take the derivative of 6y with respect to y. So this makes a lot more sense. But these are not equivalent because we just changed this dx into a dy, so we need to account for that change. And we're going to do that by multiplying by a dy dx. So imagine that these dy's and dx's were just numbers. The dy's would cancel out and we'd be left with a d6y over dx. So now we can do that. So the derivative of 6y with respect to y is 6. And then we have to tag along that dx. So that's pretty much that's gonna be the story with implicit differentiation. If we take a derivative with respect to y, since we're in dx, we're just gonna have to tag along this dy dx and then just take a normal derivative. So when I explain it like that, I mean, some people find it really confusing, but now let's go over a practice problem and you'll see that it's just a method. It's just that every time that you take a derivative of y, you have to add that dy dx along. There isn't much to think about. So the question is to find dy dx, and the expression, the implicit expression is x squared plus xy plus cosine y equals 8y. So as you can see, we have x's and y's on the left side and just y's on the right side, so it's an implicit expression. So let's go ahead and do this. So let's start with this x squared. The derivative of x squared with respect to x, that's just 2x. Now let's take care of this xy. So this xy, what we're going to need to do is we're going to need to use the product rule. So remember, the product rule says that we take the derivative of the first term. So the derivative of x with respect to x is just 1. And then we multiply it by the second term. So 1 times y is just y. So we don't need to add a dy dx because we didn't take the derivative of y. Y was just there. Y was just a constant. But on the second part of the product rule, where we just leave this x alone, and we take the derivative of y. So now we're taking the derivative of y, and since we're doing something like this where we're taking it with respect to dx, we have to multiply by dy dx. So now that we're taking the derivative of y, which is 1, we have to add a dy dx. So all you have to think about is that if you took a derivative of y, you have to multiply by dy dx. So let's look at this cosine y. The derivative of cosine is negative sine. So we have a negative sine y. But once again, we took a, I'm just going to get rid of that. We took the derivative of y, so we have to add a dy dx. And once again here, the derivative of 8y is going to be 8, but we took a derivative of y, so we have to add a dy dx. And now from here, we just have to solve for dy dx. So we're going to move all the dy dx's to the left side and all the non-dy dx's to the right side. So first of all, I'm going to rewrite it without the parentheses. So 2x plus y plus x dy dx minus sine y dy dx equals 8 dy dx. Now I'm going to move all the dy dx's to the left and all the non-dy dx's to the right. So we have an x dy dx minus sine y dy dx minus 8 dy dx. Move this 8 over. Now I'm going to move all the non-dy dx's to the other side, so we have a negative 2x minus y. And this method that I'm doing right now, you can pretty much use it for every implicit differentiation question, which is taking the derivative, moving all the dy dx's to one side, all the non-dy dx's for the next side. Then what we're going to do is we're going to factor out the dy dx, and we get an x minus sine y minus 8 equals negative 2x minus y. And then we're just going to divide by this term, and that gives us dy dx equals negative 2x minus y over x minus sine y minus 8. So once again, whenever you're doing, this is just I divided by this term. So whenever you're doing an implicit differentiation question, all you're doing is taking the derivative of each term. If you take a derivative with respect to y, you just multiply by dy dx. Then you move all the dy dx's to one side and all the non-dy dx's to the other side, and factor and divide. So, just for fun, let's do that expression that I wrote in the beginning, which is x squared plus xy equals 6yx plus 6y. First things first, I'm going to move this 6y over. So we get an x squared minus 5xy equals 6y. Now I'm going to take the derivative of both sides. Derivative of x squared is 2x, and then minus 5 times. Now we do the product rule again. So we take the derivative of x, which is 1, times y, plus the derivative of y, which is 1 times x. But once again, since we took the derivative of y, we just need to add a dy dx, or multiply by dy dx, and that equals to the derivative of 6y, which is 6, and once again we took the derivative of y, so dy dx. Now we take care of this parentheses, 2x minus 5y minus 5x dy dx equals 6 dy dx. And now we're going to move the dy dx's to one side and then the non-dy dx's to the other side. 2x minus 5y equals 6 dy dx plus 5x dy dx. Factor out the dy dx's. And we have 6 plus 5x. And now divide and solve for dy dx. So dy dx is equal to 2x minus 5y over 6 plus 5x. So once again, it might seem difficult to think about it like this every time of why you have to add this dy dx. It's much easier to just understand that whenever you're taking a derivative of y, you just add this dy dx. And that's how you do implicit differentiation.